Hello everybody, welcome to this introduction to hipSYCL. My name is Axel Alpay, I work for Heidelberg University and I lead the hipSYCL project. hipSYCL is an open source SYCL implementation led by Heidelberg University. You can go check it out on its GitHub page. Unlike other SYCL implementations which rely mainly on OpenCL, hipSYCL is built on top of OpenMP, CUDA or ROCm with no additional layers in between. In hipSYCL, we rely on the Clang, CUDA or hip frontend with an additional hipSYCL Clang plugin to add support for SYCL constructs. Because of this architecture, since the code still goes through a hip or CUDA toolchain, kernel performance can be expected to be on par with Clang compiled CUDA or hip by design. In addition, the hipSYCL compiler understands not only SYCL, but also CUDA or hip, so you can really mix and match SYCL and CUDA or hip code in the same source file, and this allows you to create highly optimized code paths for specific devices. It also gives you full CUDA or hip interoperability and allows you to use vendor tooling, optimize vendor libraries, CUDA or hip template libraries, even the latest device intrinsics, and so on and so forth. If you want to install hipSYCL, the easiest way is to use our package repositories. We provide Debian, RPM, and Arch Linux packages, not only for hipSYCL itself, but also for matching LLVM and ROCm distributions. There are also some community-provided packages. For example, there is a spec package for the CPU and CUDA backends. The ROCm backend is not yet supported. There are also ongoing packaging efforts in the communities of Gentoo, NixOS, and the Arch Linux AUR. If you use spec, then installing hipSYCL is as easy as typing spec install hipSYCL at master plus CUDA if you want to have CUDA support. Of course, you can also install it from source. This is also documented on the GitHub page. If you compile code with hipSYCL, you use the SYCLcc compiler wrapper. It's also sometimes referred to as SYCLcc Clang. It's exactly the same thing. You can either type SYCLcc or SYCLcc Clang. It makes no difference. SYCLcc hides all the nasty details. For example, how to invoke the compiler correctly, how to load the hipSYCL Clang plugin if it needs to be loaded, linking against hipSYCL, setting the correct include paths, and so on and so forth. SYCLcc behaves exactly like a regular C++ compiler, so you can use your regular optimization, C++ optimization flags and any other flags that you can use, for example, for Clang, you can use with SYCLcc. In addition, SYCLcc provides a couple of hipSYCL specific command line arguments, such as --hipSYCL platform, which can be used to set your target platform to CUDA, ROCm, or CPU, depending on what you're targeting. If you're targeting GPU, you can also use --hipSYCL GPU arch to set your target GPU architecture. And if you're compiling for CPU, you can use hipSYCL CPU CXX to set your CPU host compiler. You can do all the same settings also with environment variables. However, if both command line arguments as well as environment variables are provided, the command line arguments take precedence. And if neither are given, then SYCLcc will just use some default settings from some configuration file that is installed when installing hipSYCL. If you don't want to use SYCLcc manually, you can also use our CMake integration, which allows you to just find package hipSYCL and then use the function add SYCL to target. This function is also provided by other SYCL implementations, which means that you can use the same CMake code to target many SYCL implementations. Since SYCL is pure C++, it can be implemented as a regular C++ library if you're only interested in targeting CPU. And this is how we have implemented the hipSYCL CPU backend. So for the hipSYCL, when compiling for CPU, you don't need a special compiler in hipSYCL. You can use your favorite CPU compiler as long as it supports OpenMP. This decision, however, is done by SYCLcc. So if you tell SYCLcc that you're targeting a GPU, then SYCLcc will invoke Clang with the hipSYCL plugin behind the scenes. If you tell it that you're targeting CPU, then it will invoke your host compiler that you have specified. One of the most interesting things about hipSYCL is the ability to mix and match CUDA and hip and SYCL code in the same source file, which allows you to create highly optimized code paths for specific devices. Let's assume that you want to create such an optimized code path for some hipSYCL platform, CUDA or ROCm or even CPU. In this case, you would first check with the hipSYCL platform macros if you're compiling for your target platform, for example, hipSYCL platform CUDA or hipSYCL platform ROCm. If you are, you can define your optimized function. If you're compiling for GPU, this function must be marked as host device, even if it only contains CUDA or hip device code. Then you can use the SYCL device only macro to check if you're actually in the device compilation path, and if you are, then you can use any arbitrary CUDA or hip device code, intrinsics, vendor optimized libraries, and so on and so forth. Then inside your regular SYCL kernel, you would again just check if you're compiling for your optimized platform. If you are, you call your optimized function. Otherwise, you call some regular SYCL function, some regular SYCL implementation for portability. We also support a couple of extensions in hipSYCL. For example, the FP atomics extension allows SYCL atomic class to operate also on floating point types if that's supported by the backend, so CUDA or hip. And then there's also an experimental extension that can dramatically simplify code that requires the same accessors multiple times in a row by letting the SYCL queue automatically require them. This can really reduce a lot of boilerplate code. And then there's the custom parallel for work item synchronization extension, which allows the user to customize the behavior of this hierarchical parallel for with respect to synchronization. This SYCL specification requires that at the end of a parallel for work item, a barrier must be executed. However, in hipSYCL, you can pass some template arguments to parallel for work item. For example, if you pass sync none to it, then no synchronization will be done at the end. In the same way, you can also tell it to do a memfence instead of a barrier, for example. If you pass no template argument at all, then it will still do the regular barrier as required by the specification. So to wrap it up, hipSYCL is an implementation of SYCL for CPUs, NVIDIA GPUs, and AMD GPUs. It provides full interoperability with CUDA or hip at source code level and really allows you to create highly optimized device-specific code paths using the latest CUDA or hip intrinsics, for example. By design, kernel performance can be expected to be on par with regular hip or CUDA. And if you're interested in learning more about how it works and maybe also seeing some benchmark results, then I recommend you check out my talk SYCL Beyond OpenCL, the architecture, current state, and future direction of hipSYCL. So go check it out on its GitHub page if you're interested. And if you have any questions, please feel free to drop me an email at any time. Thank you.